Hey Donnie, why do you look so stressed?
Oh, hey Nappy. It's just this unit of calc. I'm having a really hard time understanding how to calculate the volume of these solids, especially the ones that have holes in them.
Well, have you tried the washer method? The washer method can be tricky, but it is exactly related to integrals and the revolutions of solids. As you might already know, the integral relates to the area bounded by a function and an axis. This function could be expressed as y in terms of x or vice versa, which would determine the axis to which the area is bound. This can be expressed as the integral of a function in between the integral a to b.
Right. I remember learning that the area between two functions is defined as the integral of the upper function subtracted by the integral of the lower function within the interval a to b, where a represents the first intersection point and b represents the second intersection point. This year we also learned about revolution of solids, where the volume of a solid was expressed by the integral between a and b of 2 pi multiplied by the radius r defined by the function.
The washer method is super helpful because it combines the area between two functions and the revolutions of solids. By using the integral, we can find the volume of the difference between two functions revolved around an axis. The washer method is based on visualizing a bunch of little washers stacked on top of each other, like these cars on the deck.
Yeah, it's just really confusing because there's usually variation in the radii of the function, you know?
Just like we learned in geometry, volume is just area compounded over an interval, or in that case, height. However, unlike real-life washers, the area of a cross-section of one revolved difference at one point will not usually be the same as that of another point. Similarly, the equation of this revolved difference is different than that of the revolved functions. Whereas a singularly revolved function has one radius, washers have two.
So in order to do that, I would have to do the integral of the larger radius minus the integral of the smaller radius, right?
Right. Before we get ahead of ourselves, let's start from the beginning. What is the very first step to washer method for revolution around the x-axis?
You've got to identify the axis of revolution, the upper function, which is big R, the lower function, which is little r, and the points of intersection. I know that the upper function is the one which has the greatest distance from the axis of revolution throughout the interval a to b. And the lower function is the one which has the least distance from the axis of revolution throughout a and b.
Right. So after you've identified the necessary variables, coordinates, and axes, we can utilize the second step of the washer method, application. Since you would have all of the information necessary to solve this problem, all that would be left is plugging in the equation.
Sweet!
So if the question asks you to find the volume of a solid revolved around the line y equals -1, and the area bounded between f of x equals 4 and g of x equals x squared, what do you know and what do you need to figure out?
I know that the axis of revolution in this problem is the line y equals -1, and I have to figure out which function is the upper function and which is the lower, and which points are the intersection points.
Good. To do that, we must graph the two functions.
The area is bounded between x equals -2 and x equals 2, where the upper function is f of x equals 4 and the lower function is g of x equals x squared. But how do you account for the axis of revolution being y equals -1?
Because the axis of revolution is 1 unit lower than the x-axis, the r function will be f of x plus 1 and little r function will be g of x plus 1. We can incorporate this information into the equation so that it becomes the interval from -2 to 2 of pi times 4 plus 1 squared minus x squared plus 1 squared dx. Then you can use your inspire to get a simplified answer.
Cool.
But sometimes on the AP Calc test, it's okay to leave your answers unsimplified and still get full credit.
Whoa, that's gonna save so much time.
I know. Okay, do you think you're ready to try a problem along the vertical axis of revolution?
Okay, but those are always so much harder because you have to change the function to be in terms of y, and it makes it super confusing.
Yeah, I know, but it helps to visualize the solid and maybe draw some cross-sections on your paper so that it's clear when to do the problem in terms of y. This question asks you to solve the volume of a solid revolved around the y-axis and the area bounded between f of x equals square root of x and g of x equals 4. The axis of revolution in this problem is the y-axis, or the line x equals 0, which indicates that we need to translate the functions to express x in terms of y.
So that means that the new function f of x equals y squared and g of x remains equal to 4. And to determine which are the upper and lower functions as well as the interval of revolution, we have to graph the two functions. I like to rotate the paper so that the y-axis is horizontal and I can tell which is the upper and lower function.
After graphing it and analyzing the function on a rotated axis, we realize the area is bounded between y equals 0 and y equals 2, where the upper function is g of x and the lower function is f of x. Keeping in mind that this function is revolved around the y-axis, we can incorporate this information into the equation, so that the integral representing this volume becomes the integral from 0 to 2 of pi times 4 squared minus y squared squared dy.
Wow, that was a lot, but I think I've got the hang of it. Do you think we could go over the most important tips?
For sure! My 3 biggest tips are: 1. To visualize the solid and sketch some cross-sections to try to sketch the whole solid. 2. Remember that there will be more than one radius function and identify which is greater. And 3. Keep in mind that if the axis of a line is parallel to the y-axis, it's a vertical revolution, and you should do it in terms of y.
Thanks so much, Natalie. That helped a lot.
Well, when in doubt, just do it!